Hello and welcome everyone. Welcome to our session, our Google Education on Air session on creating assessment activities for the digital technologies curriculum. We're so excited that you could be here to join us today. I'm Rebecca Vivian. I'm a researcher, an educator and a Google certified innovator.
Hi, and I'm Katrina Falkner. I'm head of school for the School of Computer Science at the University of Adelaide, but also lead for the CSER Digital Technologies Education Program. It's really lovely to have you here with us today, and we're really looking forward to talking to you about assessment within digital technologies.
Okay, and a little bit about our group. So we're the Computer Science Education Research Group at the University of Adelaide. We undertake research into computing education, but we also run a free national teacher training program in Australia to support teachers to implement the digital technologies curriculum. So today we've got a jam-packed session looking at assessment strategies for digital technologies. What we'll do is consider the role that assessment can play in preparing students for the future and look at some assessment approaches and examples that you can try in the classroom. And lastly, we'll end with some Q&A. We've designed this session so that it's not tied to any particular digital technologies curriculum, rather that it's around the fundamental principles and topics. So whether you're joining us from Australia, New Zealand, or somewhere else in the world, we hope that you're able to take some ideas and adapt them to suit your context. If at any point during the session you have a question, please ask away, and when we come to the end, we'll spend some time answering your questions. Just before we get started, just to let you know, please adjust your streaming quality to 720p. This is for best viewing, and you can do this with the cogwheel at the bottom right of the video.
So the skills that our students require to thrive in the workforce are definitely changing. A recent report by the Foundation of Young Australians reveals that jobs of the future increasingly demand what we call enterprise skills. And these are listed on the left here, and they're things like problem solving, critical thinking, creativity, teamwork, etc. And they've been found to be a really powerful predictor of long-term job success because they're transferable skills that enable people to navigate jobs. All industries, whether it's manufacturing, science, IT, or finance, employers are demanding enterprise skills as in equal amounts to technical skills. You know, often when we think about computer science or ICT, we think about the technical skills as being the core aspect there. But what we know from industry and what we know from our own students moving forward into their careers is that the enterprise skills, you know, the capacity to problem solve, to think critically and communicate are equally important. For New Zealand as well. You know, the New Zealand Careers website identifies 7 key employability skills that we show here, and these are all enterprise skills. And because of this, we know that digital technologies is much more than about programming. Enterprise skills are core to success of digital innovation. You know, as Bill Gates states, software innovation requires the ability to collaborate and share ideas with others and to talk with people to get their feedback. And one key word relevant to today's session from this is definitely feedback.
So evaluation is a critical process in digital technologies. Here we have an iterative design model, and you can see that evaluation is not something that happens at the end. It's a critical point that informs ongoing design and development. Involving students in the process of assessment can support them to understand the critical role of evaluation and feedback in digital technologies innovation. Assessment and feedback is therefore a key part of digital technologies learning, and this is captured in key thinking processes that underpin digital technologies curricula. For example, design thinking has a series of stages in which students test and pilot projects, all of which assessment can play a key role. Computational thinking also includes skills in which students are required to iteratively evaluate, test and review their ideas and understandings. And that's a really important aspect. For example, we cannot simply create an algorithm without testing it to see how it works and how we can improve and learn from it. When we think of an assessment, in today's session, we'll look at assessment activities that support different assessment purposes. So we know we have assessment of learning, which is typically your summative assessment. This involves teachers using evidence of student learning to assess achievement against curriculum outcomes and standards. We also have assessment for learning, which is formative, and this involves teachers using evidence about students' knowledge and skills to inform their teaching and to provide students with feedback that informs and improves their learning. And that's something that you should, teachers typically do throughout the learning experience. Then lastly, we have assessment as learning, and this isn't as common, but something we're trying to promote in today's session. So this is when students are quite responsible and they're actually the assessors in their learning experience. So students monitor their learning and they use a range of strategies to decide what they know and what they can do and what they need to learn or improve on. Important for developing those enterprise skills.
Now, before we look in detail at different assessment approaches, we wanted to really take some time to draw the distinction between the ICT capabilities or digital literacy and digital technologies. We're going to use an example here of a visual programming project using Scratch. And in this example, students develop a project that teaches someone the Gadigal language, a language of an Indigenous community in New South Wales. Now, on one side, we have the ICT capabilities, and on the other, we have digital technologies. Now, assessment of ICT capabilities considers things like the ability to locate data and information using digital sources. So this might be finding reliable sources such as the information about the Gadigal peoples and their language. It also looks at the ability for students to recognise intellectual property, such as referencing the appropriate sources for the project, or referencing another Scratch project that inspired them or helped them. It also looks at things like the use of ICT tools to generate and plan ideas. And, you could think of an example here as a mind map to plan out the languages project. Things like management of digital data, so using appropriate file conventions and folders to store and manage your digital artifacts. But on the other hand, we have digital technologies, and digital technologies includes things like determining what data is required for the Scratch project, where to source it and how to store it in the actual Scratch project itself. Things like algorithm design, which is the ability to decompose a problem and develop algorithm designs or the design of a user interface of the project. And then things like implementation of the actual visual programming, the core of actually getting this to work. So looking at the code the students have used, their ability to test and debug their programming project, and then looking also at evaluating and assessing it.
There are many different ways you might assess student learning in digital technologies, as well as ways to engage students in assessment as learning. While there are some approaches such as programming assignments or challenges, artifact analysis, and cognitive interviewing, which are popular assessment methods in computing education, many of the methods you're already using in the classroom for other subject areas can be adopted for digital technologies. One familiar activity that teachers can do, for example, is to assess where students are at the beginning or the end of a unit of work, is to brainstorm in some form words that you can think of for a particular topic. So this could include images, facts, words, definitions, opinions that students have about a subject. And this is a great one that can be done quite quickly, for example, as a 5-minute challenge or with more time. And it works for a range of age groups. So this can be done on paper, simply having students write words alongside letters of the alphabet, or alternatively, it can be used done digitally. So by having students assign words or images to each of the letters on a template. For example, on this Google slide, which you'll be able to have a play around with after this presentation, we've been brainstorming for a unit on digital systems. So we've been thinking of words related to hardware, software, and networks. Slides as opposed to paper allows Katrina and I to manipulate and edit the slides at the same time. And a variation could be to have students add images. So we could use the image function to insert images that we find from the web, or students could even take images of their surrounding environment, so where they're finding hardware and software around them in the classroom or at home. In these types of activities, teachers are looking for terminology used by the students. So is it ticking the content descriptors or learning objectives in your curriculum? Also the difficulty associated with the keywords, the level of topic coverage, the focus. So have they stayed on topic or have they spanned out to more irrelevant topics? And this helps teachers identify gaps in knowledge or topics and can help inform future instruction. So another way to assess students' knowledge is to have students explain or demonstrate their knowledge in some way. So you could have students do presentations, prepare posters, essays, or do live demonstrations. One tool I'd like to share with you that teachers love in our online teacher community is Seesaw. For example, I'm just going to pull up the Seesaw application. What this does, Seesaw is a student-driven digital portfolio. So students can create, reflect, share, and collaborate within a safe online environment. So you can invite your class to this application. Students can access it via apps on digital devices, or it's also available as a Chrome add-on through the web browser. And what students can do is create, reflect, share, and collaborate within this environment by using particular functions. So teachers can set up their own activities for students, and this is a great way to assess student knowledge. So here we've got a few examples that you can see. I'd like to just draw your attention to the Bebot one. So you can see here we've created an activity where we're inviting students to add words, perhaps after doing a unit on using Bebots in the classroom, and we're trying to determine if students can articulate how to use a Bebot and if they can identify the features of a Bebot. So the Seesaw application allows you to upload images that you might want students to edit and label. Can then use these little functions, so they can take photos themselves and upload them if you're asking them to take a photo of their Bebot, for example. You can then get them to use the draw function, so you might ask them to circle points on the image or even label them using text. There's also a feature to be able to use the microphone, which means that students can actually explain. So in this example, we've asked students to explain how to use the Bebot. And what's great about this is you can have instructions, so I can actually record my own instructions and students can listen to what they need to do if they're not sure about the text instructions. And then teachers can review this, students can share created content within this online environment, and other students can actually comment and provide feedback. This same activity, say for an older audience, could be done using an activity around identifying peripheral devices. So, for example, after a lesson on looking at input and output devices, you might propose an image that students then need to label to identify what devices in this image are input and which ones are output. And then you could invite them to use the microphone to explain more about these devices and distinguish the difference. So I'm just going to jump back into this, into our presentation. So for your reference later, we've also put a table there which helps you identify perhaps keywords that are appearing in your curriculum and what features in the Seesaw app that you might use to draw out that knowledge and skill. And we've just placed them there for your reference too. So once students have completed their assessment activity, teachers could use something like a checklist to evaluate whether students have demonstrated a particular knowledge or skill. For example, in the case of the input and output devices, you might be looking for a particular number of items identified in the photo, or that they're able to articulate the difference between the two. So with checklists, you can use the curriculum outcomes or the achievement standards to guide your checklist development and develop items that are specific and measurable. So you really want to be able to pinpoint the knowledge and skills and gaps. But teachers are already doing this for other learning areas, so it's just about translating that to digital tech. Engage older students in assessment processes could be to have them use a checklist template to assess a peer's explanation that they've shared on Seesaw or some other tool. So another way to assess students' content knowledge could be to use quizzes. So you could use quizzes for exploring how students can identify digital technologies, networks, devices, or features. You could use it to evaluate their understanding and code comprehension, or even their computational thinking processes. So we've got some suggestions there on the left such as Kahoot, Pear Deck, which is an add-on with Chrome, Google Forms. It could even be using something like the Bebris Computational Thinking Challenge questions as some formative assessment measures, as well as Project Quantum, which is a special computer science online repository that's being developed by the community. So the community is submitting quiz questions. So one example I'd like to share with you is from our community. So David, he has his students, after they've completed some online visual programming activities, he really wants to test their code comprehension skills. So what he does is he gives students puzzle activities. So half the room have the maze example, and then the other half of the room have the code that matches the maze examples, and they have to try and pair up and figure out which code or character to the end of the maze. So another way that you could do this type of activity is to use something like the Google Forms. So we love this as a way to explore code comprehension. Within Google Forms, you can create multiple choice questions. You could have open text opportunities. Within this, you can actually add images. So you could upload blocks of text like I've done here. It could be visual programming, or it could be with a general purpose programming language. And then you might ask questions using multiple choice or checkboxes that try to get students to respond. You also have the ability to add videos. So you might play a video of a bee-bot moving around the mat, or some kind of technology, and then ask students to respond to that video in some way. A really good way to have students, I guess, demonstrate their understanding is to also have open text responses where you're asking students to explain why they've selected that answer, or to elaborate a little bit more on perhaps where they've used that in their learning, or providing examples. So what's great about this is you can actually go straight to the responses. So you could have students come in anonymously, or you could have them write their name, and then you can look at their individual responses to the questions. So it could be something that's used formatively or summatively. So another quiz example I'd like to share with you comes from teachers in our online community. So teachers have been sharing the use of Kahoot. They've been developing quiz sets for digital technologies, which is great, and sharing these in the community. Some examples include identifying computer parts in the classroom, or a video, looking at binary numbers, or even a follow-up test after using robotics in the classroom to try and really understand, our students understanding the concepts behind what they're using in the classroom. And as with the Google Forms, this is a really great way to identify misconceptions and gaps in knowledge. So Kahoot has the ability where teachers present this on a board, or students can interact with this using an app interface. So another example we've got is digital portfolios. And in digital technologies, assessment is typically focused on the product at the end, such as programming projects like an app. However, there's a number of learning processes that lead to the development of final projects and artifacts that can be collected along the way. And this is a really great opportunity for formative assessment, as well as inviting students to engage in being assessors. So examples, if you're looking at digital portfolios, you could collect artifacts which include photographs of projects and code. You could have students submit videos of projects, documentation. You could have them use voice, video, or text to engage in explaining, reflecting, and evaluating on their learning process, as well as the project they've developed. You could get them to also submit self-peer or even teacher evaluations and feedback. So I just want to quickly show one way that you could present this, particularly for the older students when their projects become quite complex and there's a lot of elements to their project. So Kat and I have just created on here using the Google Sites feature. So we've created a mock project site here, And it's quite simple, like students can come in here. What we've done is we've just essentially dragged and dropped videos. So you can click on any of these features on the right here, such as docs, slides, sheets, and then you just drag them and insert them into your projects. So let's have a look at what this looks like in practice. So this mock project, we've got our animation here, which students can come and have a look at, other students in the class. We've put our planning documents in there, so peers can actually come in and see how we've gone around designing our solution. We've also included our code, and the great thing about this is it's done with Google Docs. So if I want students to come in and comment on my code, they just come and click on the document. They can have a look at my code. They could even copy it if they really wanted to try it in their own programs, or they can write comments on the code. So that's a great way to really engage peers in feedback processes. We've also included Google Forms, so you could actually invite students in the classroom, even community members or family members, to come and provide feedback. Okay. So I think we're just going to touch on a few other examples that you might want to consider in something like digital portfolios.
Yeah, so think alouds are one of the other techniques that we often use ourselves in our research, but also in assessment for students here at the university. And essentially the idea is to get students to talk through their learning. So you get them to explain, to talk, maybe make a video or do a demonstration of their digital project, explaining the purpose, talking through their design decisions, how it works, cleaning up the processes and underlying technology, and also the user interaction. And this really gives a good feeling for how well the students understand what they're doing rather than just having necessarily implemented it. The next one, I guess, that you can use a lot, and we also, again, use a lot here, is the idea of self and peer assessment. And self and peer assessment can be used by students to provide feedback on peer projects. It can be used to provide feedback on performance and teamwork, but also the usability of projects. And here we have a couple of examples from teachers in our community. We have one teacher using the idea of having students sending projects to peers to test and evaluate using a rubric. Using Google Forms to collect anonymous peer data about their projects, so getting anonymous feedback from a larger group of students. And using peer evaluations via recording experiences using video and sending this back to students. Aspect of the evaluation process and a really good preparation for the skills that students will need as they go into the workforce. Because what we're looking at here is building up not only the skills to give feedback and to receive feedback, but also then reflecting on how you can take that into the process and use that to evolve and improve your digital system as you develop it.
And one way to support self or peer assessment could be with use of rubrics. So what you can do is use the achievement standards to really develop the elements and the levels of complexity that you're looking for. However, one way could be to have students to co-construct the rubric, and this becomes a learning experience in itself. So in this example from our community, Sue shares how she has her students co-create a rubric for evaluating user interfaces. As a class, they start by individually identifying what they think are the essential elements to consider when designing a user interface. And as a class, they start to bring these ideas together until they've refined a key list and developed a rubric around that. Then what Sue does is she guides them through this evaluation process using example user interfaces. And then lastly, they go away and they conduct peer evaluation using their shared constructed rubrics. So this is a great way to have students take ownership over assessment as well as develop their assessment skills in a scaffolded way. Engaging students in assessment processes and highlighting the importance of assessment as a learning process can help build student resilience. So let them know that we learn from evaluation and that feedback helps us to improve and grow. And as Elon Musk said, it's very important to have a feedback loop where you're constantly thinking about what you've done and how you could be doing it better. To be constantly thinking about how to improve, how to question themselves. This involves providing opportunities and safe environments to engage in assessment, as well as guiding them in how to use feedback and support their growth. So lastly, if you've enjoyed some of the examples here, some of the community contributions, we run a national program. So we have free online courses. Anyone in the world can join, really. We have Peel in a Box, which supports educators to deliver professional development using ready-made packs. And we also have a lending library for Australian teachers and free online resources such as lesson plans and guides for anyone really.
And I guess one of the most exciting aspects of that, and as we've seen over the last 4 years of working with this program, is all of the amazing teacher contributions shared with the community. And we've shared some of those with you today, but I really encourage you to come and check out the courses, but also check out the community and see what other teachers are doing with digital technologies. And it's so helpful, I know, in being able to look at what you could do in the classroom. We have had a couple of questions that I think we can talk through towards the end of our presentation today. Just for the several of you who've asked whether you can have the slides, of course. So there is a link already to the slides on the front page, but I've also replied to your comments with the link there, so you can get that directly.
I should also mention that you'll have a link to a handout. So on that last slide there, we've put a link to a handout with more references to information.
Indeed. And there's links all through the presentation to the various demonstrations that we went through today. So the Seesaw demos and everything, they're all linked in so you can get them from the presentation slides. There was another question that you might be able to answer, Beck, that we had, which is on the project form with the comments, is there a chance for students to accidentally delete what was there? As in, like, do you need to keep a blank template or something in a different folder?
That's a great question. So you could encourage students to always have a backup of their work, so copying the Google Forms if they're sharing that with other students. But what you can do is you can actually set your Google Forms or your Google Slides to have features where you can share with people, but they can only view and comment, but not actually edit. So that stops that deleting process.
Fantastic. And I know a couple of other people have asked for the link again to the courses that we have. So I'll write it into the comments as well, into the questions, but it's csermoocs.adelaide.edu.au. So that will be, we'll put that in as an answer to the questions, but that's where you can find further information about the courses. Now, I know on Twitter as well, there were a couple of people talking about how much they liked using Seesaw as well. So I don't know if there are any other examples that you've seen back of people who are using that? Or?
Yeah, besides using it where teachers are creating assessment activities, we've seen a lot of teachers in our communities using it as a way for students to document their learning. So because students can actually record videos or use the microphone, they could even engage in some reflection exercises where they're just sort of reflecting about what they've learned during that lesson, or even sharing videos and photos of what they've done that have been annotated. So that's a great way to engage with parents as well and really get them excited and aware about what digital technologies is and what students are doing in the classroom.
Oh, fantastic. Now, I'm just checking again for any final questions. I think we may have answered all the ones that you've had.
What I'll do is I'll just pop over to our final slide.
Oh, there was one more quick question that I think we can talk about. So Bill's asked us that, assessing video explanations costs a lot of real time, also giving feedback. Peer assessment is one way that you can address it, and I really agree, Bill, that's a really good way of doing that, but how does the teacher find the time to do the assessment?
Yeah.
How will that work?
No, that's a very good question. Probably peer assessment, perhaps but keeping it short and simple. So you might give students a limit, perhaps that they have 1 minute to cover some key points that you're really looking for. So perhaps don't waste the time, really provide criteria on what you're wanting students to unpack in their explanations. They could even just use it as a personal documentation process. So perhaps getting the students to self-assess. So perhaps watching their videos and evaluating how they've grown as a learner in their project. Or what they're doing in the classroom.
Yeah, no, that's a great idea. Okay, well, so I think that's it for now. Thank you so much for listening to us. I hope it's been really useful. It's been really fun to go through and talk with you all. I think, yes, just the last slide. We'll put the slide up.
Yeah, we'll put the slide up. You can have a look at our final details and tweet and enjoy the rest of the sessions.
Yeah, and do get in contact with us if you wanted to talk further about what we're doing with CSER or about assessment ideas in general.